Hi guys, so today we're going to be learning about graphing rational functions. So what a rational function is, it's a function of the form f of x equals p of x over q of x. And really all p of x and q of x are they are polynomials. Okay, so it's basically just a function that's a ratio where the top part is a polynomial and the bottom part is a polynomial. Okay, and then the polynomial on the bottom cannot equal 0 because then it would make it undefined. Okay? So one thing special about the graphs of rational functions is that they sometimes have breaks in continuity. And what that means is that it can't be traced with a pencil leaving the paper, right? So if it's continuous, that means you can trace it all in one go, okay? With a rational function, that can't happen because it has breaks in continuity where there are values that aren't part of the domain. Okay? And this often appears as a vertical asymptote or as a point discontinuity, which is a hole. Okay? Rational functions not only have vertical asymptotes, but they can also have horizontal asymptotes. And all an asymptote is it's a line that the graph of the function slowly approaches, but never actually touches, right? So the way that I think about it is like in Finding Nemo, you can't touch the butt. Butt sounds like, the word asymptote, right? So that it just means you can't touch it, and the function doesn't touch it. It approaches it, but doesn't touch it. Okay, and a point discontinuity is like a hole in the graph. Okay, so here there are several examples. So here there's an example of a vertical asymptote here, because here what would make the bottom undefined is if x was 3, right? And so that is why there is a vertical asymptote. Okay, in this rational function, right, there ends up being a point discontinuity or a hole, because here, even though x equals -2, right, would make it undefined, but because it's both on top and the bottom, it gets crossed out. And so as a result, there's only a hole in the graph, and we see that right here, right, with this circle. And, which means that it is not part of the graph. That's why it's an open circle here, okay? So a vertical asymptote is when that bottom part will equal 0, wherever that is, that will be a vertical asymptote. The hole is when we have that in the denominator, but it also appears in the numerator where we cancel it out. Okay. So let's get started with my first example. Okay. So we're going to determine the equations of any vertical asymptotes and then or any values of x for the holes in the graph. Okay. So what I'm going to first do is I am going to factor this. So x squared minus 1 is x plus 1, x minus 1, and then x squared minus 6x plus 5 factored is x minus 5, x minus 1. Okay? So here, I see that x minus 1 is canceled out. Okay? And so what this does is it creates a hole there at where x minus 1 equals 0. So add 1 on both sides, x equals 1. There is a hole where x equals 1. Then the other one in the denominator that wasn't crossed out was this x minus 5. Okay? And if this equals 0, this would make it undefined. So we would have to have an asymptote here. So add 5 to both sides. That gives us x equals 5. And here, there is a vertical asymptote. Okay? There's a vertical asymptote at x equals 5. And there's a hole at x equals 1. We would find the y coordinate of the hole by plugging it back into now the simplified version. Right? So we would plug in 2 here, so 2 would be the numerator, and then -4, so this would be at -1/2. Okay? Yeah. So then in this case, let's see, f of x equals 1 over x squared plus 2. This isn't factorable, right? However, we need to figure out what would make this denominator equal to 0. So I'm going to set it equal to 0. Subtract 2 on both sides. This is -2. Square root both sides. This would be x equals positive, negative, square root of negative 2. This is an imaginary number, so that means there's nothing that would cause it to be undefined. So here we have no vertical asymptotes and no holes. So no vertical asymptotes and no holes for that one. Okay. So why don't you try this next problem and then come check your answer when you're done. Okay, you should have gotten that you'll have a vertical asymptote at x equals 4 and a hole when x equals negative 4. Okay, if you got that right, you can move on to the next section. If not, here's your explanation. So I factored x squared plus 6x plus 8 to be x plus 4, x plus 2. I factored x squared minus 16 to be x plus 4, x minus 4. Okay, because the x plus 4's cancel, it tells me there will be a hole there. So I set that equal to 0, and that gives me negative 4. So the hole is when x equals negative 4. Okay? So then this is what remains. And the thing now that would make the denominator equal to 0 is if this, x minus 4, equals to 0. Add 4 on both sides, so x equals 4, vertical asymptote there. Okay? So something special about rational functions is that they also can have horizontal asymptotes. Okay? And so to find the horizontal asymptote, what we're going to do is we compare the degree of the numerator, so here it's represented by n, to the degree of the denominator, and as a result, there are 3 different cases. Okay? The maximum number of horizontal asymptotes we can have is 1, so you don't have to worry about having like a gajillion of them. The most it can have is 1. Okay, so if the degree in the numerator is bigger than the denominator, example here, right, this is a cubed, this is just linear, 1, then in that case you would have no horizontal asymptote. Okay? If the numerator and the denominator have the same degree, then it will be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So here's an example here. They're both x squared, so they're both quadratic, okay? Right, and so then in this case, the asymptote will be y equals, leading coefficient for this is 4, leading coefficient for this is 1, so 4 over 1, that's 4. So the asymptote will be at y equals 4. Okay? Then the third case is if n is less than d, so if the numerator power is less than the denominator power, it's going to be y equals 0, it's going to be your x-axis, okay? And we see that here, this is linear, the bottom quadratic, right? So then this is bigger than this, right? So then it will be at the horizontal asymptote, okay? So here, for when the numerator is bigger than the denominator, it says no horizontal asymptote with 2 little asterisks. So what it says here is if the degree of the numerator is exactly 1 greater than the degree of the denominator, what we're going to have instead is a slant asymptote. And we can find this by doing long division on the rational function. And what results is your slant asymptote. Okay? Okay, so with all that information now, we're going to be graphing our rational function. So first, we're going to factor it, the numerator and denominator. We're going to find any holes and asymptotes. We're going to find intercepts. And then we're going to find and plot any additional points. We should probably have at least maybe 1 point between and 1 point beyond our intercepts and vertical asymptotes. And then we're going to connect the points that belong to the same branches. Okay? So here we're going to start first by factoring the numerator and denominator. That's done for us. It's already factored. Then we're going to find any holes. So here, since there's nothing to cross out, there's going to be no holes. So under holes, I put none. Okay. However, we do have a vertical asymptote, right? X minus 5 equals 0. So then that means x equals 5. That's going to be our vertical asymptote. Okay. And then horizontal asymptote here. The numerator degree is 0. The denominator degree is 1, so this means that n is smaller than d, okay? And so what happens then? So here, if the numerator power is smaller than the denominator power, y equals 0 is going to be our horizontal asymptote. So we're going to have a horizontal asymptote at y equals 0. Okay. Then, because our asymptote is at y equals 0, this is the x-axis. That means that we're going to have no x-intercept. Right? And then for y-intercept, we're going to plug in 0 for x and solve for y. So this becomes 4 over 0 minus 5, which is negative 5. So this is going to be 0, negative 4/5. Okay. So now let's kind of graph a little of what we have. So I'm going to zoom it out a little. Okay. So we have no holes. We don't have to worry about that. We have a vertical asymptote at x equals 5. So 1, 2, 3, 4, 5. So here I'm going to draw my asymptote, okay, which means I will approach this but never touch it. So this is my vertical asymptote. My horizontal asymptote is at y equals 0. Okay. And so all I'm going to do is I'm going to plug some points in. Right? And then I have a y-intercept at 0, negative 4/5. So that's about here. Okay. So then let's just plug in some points. So make a table. Okay. So maybe let's do some like negative 2, negative 1. We already have 0. Right? This is our intercept. Right? Let's do some that's a little bit closer here. So let's skip around a little. Let's do 2 and 4. Right? And then let's do some beyond our this asymptote. So let's pick something like 6 and 8. Okay, so now I'm just going to plug these in and I'm going to figure out what this is. Okay, so here, this is negative 2 minus 5, that's negative 7, so this is negative 4/7, right? Plugging in negative 1, this is negative 2/3, so not very helpful. Maybe I should have done some beyond that. Plugging in 2, this is negative, so 2 minus 5 is negative 3, so negative 2/3. Okay. 4 here, negative 1. This will be negative 1, so this will be negative 4. Okay. Plugging 6 here, that will be positive 4, right? Because 6 minus 5 is 1, 4 divided by 1 is 4. This will be 4/3. Okay. And then we're just going to kind of see what we get. Okay. So I have negative 2, negative 4/7. So that's about here. Okay, negative 2/3. Right, so I really don't need to do any more because it's going to get closer. Oh, sorry. I don't really need to do any more because it's just going to get closer and closer to this, but not touch it. Okay, so now I'm going to do 2, negative 2/3. So that's about here. That's weird. It went back up again. Okay. Well, let me check. Negative 6. Nope, that is right. 2 minus 5. It is. This is negative 4/3, right? 2 minus 5 is negative 3. So this is negative 4/3. So let's move that. Negative 4/3 is here. Okay. 4 negative 4 is 1, 2, 3, 4. It's about here. So on this left branch, I already know it kind of looks something like this. Okay. This branch, right? So where I'm getting closer and closer to this asymptote but not touching it, getting closer and closer to this asymptote but not touching it. Okay. Then for 6, I have 6, 4, so that'll be here, 1, 2, 3, 4 here. And then I have 8 at 4/3. So that'll be here, and 4/3 is here. So it should look something like this, probably. And then here I will also get closer and closer to the asymptote but not touch it, get closer and closer to the asymptote but not touch it. Okay, so now let's try our next one. Okay, so following the same things, we're going to first factor the numerator and the denominator. So this is x plus 2, this is x plus 1, right? This is x plus 2, this is x minus 1, okay? So here, since I cross out the x plus 2, there's going to be a hole there, so the hole will be at x equals negative 2. Right? And I need to figure out what the y value will be. Right? So the whole results from this. Right? This will give me a vertical asymptote. So the vertical asymptote will be at x equals 1. Okay. Here, since the power is the same, I'm going to get a horizontal asymptote. Okay, so since the numerator and the denominator have the same power, it's going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator, which in this case is just 1 over 1. So horizontal asymptote at y equals 1. Okay. So then, to find my y-intercept, right, I'm going to plug it in to here and find my x-intercept as well. Right. So to find my x-intercept, you plug in 0 for y equals this x plus 1 over x minus 1. Okay, multiplying x minus 1 doesn't do anything to both sides, so that's 0 equals x plus 1. And then this is negative 1 equals x, so my x-intercept will be at negative 1, 0. Okay. For my y-intercept, we're plugging in 0 for each, so this will be y equals 0 plus 1 over 0 minus 1, which will be negative 1. So my y-intercept is at 0, negative 1. Okay. And then, now, I'm going to need to find my hole. Okay, so let's start by graphing some of what we know. Okay, so my vertical asymptote here and horizontal asymptote are both at 1, so this is my vertical asymptote. Okay, and then my horizontal asymptote is here. Okay, so then I'm going to make my table. Okay. So I already know that x-intercept is at negative 1, 0, so that's here. And then my y-intercept is here. Okay, so maybe I'll do something like negative 3. Oh, negative 2. So let's do negative 3, that's beyond the hole. Negative 2 here is going to be where my hole is. We already know negative 1, 0, that's the x-intercept. 0, negative 1 is the y-intercept. And then 1 is my asymptote. So then let's just do a couple beyond that. So 2, 4, and then maybe 6. Okay, so I'm going to plug it into the simplified one. Okay, so negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4, so this is 1/2. Right? My hole here, negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. Okay, and so the hole is going to be at 1/3. Okay, 2 here, 2 plus 1 is 3. 2 minus 1 is 1, so that'll be 2, 3. 4 plus 1 is 5. 4 minus 1 is 3. Okay. And then 6 plus 1 is 7. 6 minus 1 is 5. So that gives me a couple of my other points. Okay, so then let's graph. So negative 3, 1/2 is here. Negative 2, 1/3 is here. So there's a hole. So then here you can see that I put a hole so that way we know it doesn't touch it. And negative 1, 0, 0, negative 1. Okay, so then this is this side, this branch. Okay. Then the other one here 2, 3, that's here. 4, 5/3, so that's about here. 6, 7, 4, 5/3 is here. 6, 7/5 is about here. And so now I can kind of connect them. And there you go. Okay. Okay, let's do a couple more. I'm just trying to show you all the different kind of cases so that way you're prepared when you have to graph. Okay. So starting with the same thing, we're going to factor the numerator and the denominator. So this will be 5, x minus 2, and then this will be x plus 3, x minus 2. Alright. So here, let it focus, since the x minus 2 gets canceled out, I will have a whole here. Right, so the whole will be at 2 comma something, right? Because the x minus 2 gets canceled. Oh, I lost the focus again. Wait. Okay. And so whole will be at 2 comma something. Then it's this one, so we can cross that out. Then this one here is going to give me my asymptote, my vertical asymptote. And that will be at x equals negative 3. So vertical asymptote will be x equals negative 3. Okay. Then we need to figure out our horizontal asymptote. Okay. And so here, numerator is degree of 1, denominator here is degree of 2. So in this case, the numerator is smaller than the denominator. Right? And so what kind of asymptote will we have? Since numerator is smaller than denominator, we'll have an asymptote at y equals 0, or the x-axis. So horizontal asymptote, y equals 0, also known as the x-axis. Right? Then let's find some of our intercepts. Because our horizontal asymptote is at the x-axis, that means we have no x-intercept. Right? Y-intercept, we plug in 0 for x and solve for y. Right? So when we do that, when we plug in 0 here for x, this becomes 5/3. So y-intercept is at 0 comma 5/3. Okay? So now, let's plot some of this stuff. Okay, so vertical asymptote at x equals negative 3. 1, 2, 3. Horizontal asymptote at x-axis. Okay, so we'll have 2 branches again. Okay. Then what we're going to do is we're going to plug in some points. So since our vertical asymptote is at negative 3, let's do some like negative 7, negative 5, and negative 4. Okay. Negative 3 is our vertical asymptote, so then let's do some like negative 2. We already have one at 0. That's our y-intercept we knew was 5/3. Let's do 2. This is where our whole is. And then maybe let's do 4. Let's see. Okay, so let's plug it in. So negative 7 plus 3 is negative 4, so this becomes negative 5/4. Negative 5 plus 3 is negative 2, so this is negative 5/2. Right. Negative 4 plus 3 is negative 1, so this is negative 5. Right. Negative 2 becomes 1, so this becomes positive 5. Hold on. Let's see. Negative 7 plus 3, negative 4, negative 5/4. Okay. Negative 5. Oh, it works. I was like, how did it go from negative to positive? Because our asymptote is here. Okay. I was like, it's going to cross. Okay, we're good. So 2 plus 3 is 5. 5 over 5 is 1. So our whole is at 2 comma 1 now. We know. And then 4 plus 3 is 7. So this becomes 5/7. Okay. So now let's graph these. So using my table, I'm going to graph it here. So -7, -5/4, 1, 2, 3, 4, 5, 6, 7. -5/4 is about here. Okay. Next is -5. -5/2, so that's -2.5, so that'll be about here. Then -4 is at -5, 1, 2, 3, 4, 5. That's about here. Okay, so this branch looks somewhat like this. Okay, then we're at -2, 5, 1, 2, 3, 4, 5. Then we have 0, 5/3. That's here, that's our intercept. Then we have 2, 1 is our hole. So that's my hole. And then 4, 5, 7. So that's about here. Okay. And so this kind of gives us a general idea of our graph. And there you go. Okay, we're going to keep going here. So again, factor. So x squared plus 2x minus 3. This becomes x plus 3, x minus 1, x plus 3. Okay. So since the x plus 3 gets canceled, that means we're going to have a hole at -3 comma something. Right? Right? Then that means we won't have a vertical asymptote, so vertical asymptote is none. Right? And then now here, our numerator power is bigger than our denominator, right? So numerator greater than denominator, right? So what's going to happen then if numerator is greater than denominator? We have no horizontal asymptote. So for horizontal asymptote, I'm going to write none also, okay? And instead, what we have is a slant asymptote, okay? And how we're going to find the slant asymptote is we're going to divide, okay? So if you remember, you can do long division for this. So this is x squared plus 2x minus 3 divided by x plus 3, right? So then times x times x will give me x squared, 3x, subtract, this becomes -x minus 3, okay, -1, right, so then -1 times x is -x, 3 times -1 is -3, and then we're subtracting it, so that turns it into positive, so 0. So I have a slant asymptote this time at y equals x minus 1. So instead, this time, I have a slant asymptote, and it's going to be at y equals x minus 1. Right? Okay, then let's find our x-intercept and y-intercept. So x-intercept is when we plug in 0 for y. So 0 equals, we're left with x minus 1, so plus 1. So our x-intercept is at 1, 0. Our y-intercept is when we plug in 0 for x and solve for y. So y equals 0 minus 1, y equals -1. So y-intercept is at 0, -1. Okay. And then I should probably figure out where my hole is. So y equals -3 minus 1. So y equals -4. So my hole is at -3, -4. Okay. So this time I'm going to start by graphing my slant asymptote because I don't have any others. So y-intercept at -1. Slope is 1, so up 1, right 1. Okay. So I want it to be quite accurate. So I'm going to plug in some points. So this is my slant asymptote. So where we know. Okay. And then here, now all I'm really left with is x minus 1. So I'm graphing the line. Sorry, in this case, there is no slant asymptote actually because all I'm left with is y equals x minus 1. Okay, so I'm going to graph it, y equals x minus 1, which I already did, thinking it was the slant asymptote. Right? So cross this out. Pew, pew. But instead, so we can see my x-intercept at 1, 0, my y-intercept at 0, 1. Now I just need my hole at negative 3, negative 4, which is right here. And so I just need to make sure I have a hole here. And this is 9. Okay. Often if it was like a cube or whatever, then we would have our slant asymptote here. Okay, but in this case we don't have one because I just was left with y equals x minus 1. Cool. Okay, so now let's do one more before you try your own. Okay. So this we're gonna graph, or sorry, we're gonna factor. So I'm gonna factor this by grouping. It might take me a while. So here, for x squared, this is x plus 2. Then this is negative 1. This is x plus 2. So I have x squared minus 1, x plus 2 when I factor by grouping. Oh, you can't see it. Oh, okay. So I factored this by grouping, right? Took out x squared here, left with x plus 2. Took out negative 1 here, left with x plus 2. So then it's x squared minus 1 and x plus 2. The x squared minus 1 results in x plus 1, x minus 1, and x plus 2. Okay. The x squared plus 6x plus 8 is x plus 4, x plus 2. Right? Since the two x plus 2's get canceled, right, that means I have a hole at negative 2 comma whatever's left. Okay? Then this will be my vertical asymptote, so that'll be at x equals negative 4. So vertical asymptote, x equals negative 4. Okay? And then here, we can see that the result here is x squared minus 1 over x plus 4. Okay? So since in this case, the numerator is greater than the denominator, this time we have no horizontal asymptote, but we do have a slant asymptote. Okay? Because this time we still have stuff on top and on bottom. Okay? So to find the slant asymptote, what I'm going to do is I'm going to divide. So this is x squared minus 1. So I should do plus 0x minus 1. Okay. And then divide it by x plus 4. Okay. So then this becomes x. So x squared 4x. Subtract, subtract. And this becomes negative 4x minus 1. Okay. So times negative 4 will give me this. So negative 4. Negative 4x minus 4. So then this becomes plus, plus. This goes away and leaves me with 3. Okay. So y equals x minus 4 is going to be my slant asymptote. Okay. So I'm going to graph all of my asymptotes. So vertical asymptote at x equals negative 4. 1, 2, 3, 4. Slant asymptote at y equals x minus 4. Okay, so I just want to clarify again about the slant asymptote. So the one before didn't because it was no longer a rational function, essentially, because we were just left with x minus 1, so then this didn't count. Okay, but here, because we do have, it's still a rational function. Once it would zoom in properly. That's why we have a slant asymptote. Okay, so we're going to put our slant asymptote here at, I guess, x minus 4. So 1, 2, 3, 4 here. And then slope is 1 second. There we go. Connecting this for asymptote. So here's our asymptote. And then now we're just going to plug in some of our points. Okay, so let's find our x-intercept and y-intercept. So x-intercept, we're plugging in 0 for y and solving x. So 0 equals essentially x squared minus 1 over x plus 4, right? The x squared minus 1 is this part, right? So multiplying that, we'll just get 0 equals x squared minus 1, add 1, 1 equals x squared, so x equals positive and negative 1, so that's our intercept, 1, 0, and negative 1. Okay. Then we have our y-intercept. We get that by plugging in 0 for y, so that will be y equals 0 squared minus 1 over 0 plus 4, which would be negative 1 4. So our y-intercept is at 0, negative 1 4. So something like this, 1 0. Okay. And then I'm gonna plot some points. So make my table. So then I would want some to the left of my asymptote here. So let's try like negative 8, negative 6, and then negative 5 is a little closer to it. And then negative 4. Then let's try negative 3. Negative 2 is where our hole is going to be. We already have negative 1, 0, 1. So let's try 2 and then maybe 4. Right? Let's plug it in. Okay, so I'm just going to use the calculator a little to help me here. So negative 8 ends up being at negative 15 and 3/4. So sadly that doesn't fit on my graph anymore. This is negative 17 and a half. Negative 5 doesn't fit either. It's negative 24. Negative 3 is at 8. So that one works. Negative 2 here. Right, right now, so negative 2 plus 1 is negative 1. Negative 3 over negative 2 plus 4 is 2, right? So negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. And then negative 2 plus 4 is 2. So this becomes 3 halves. Okay. 2 we have 1 half. And 4 we have 1 and let's say it's 5, 6. 7/8. Okay, so here you can't quite graph it. So what you should know is that here, essentially, it'll look something like this. Okay, sadly, it just doesn't fit. Okay. However, negative 3 does fit. So 1, 2, 3, negative 3, 8, 1, 2, 3, 4, 5, 6, 7, 8. That's here. Negative 2 is where my hole is, so that will be our 3 halves, so the hole is around here. Okay. We already got negative 1, 1. 2 is at a half, so that's here. And then 4, which is about here, is at 1 7/8. So here, this branch basically looks something like this and goes beyond. Okay. So sadly, this side didn't fit, but there you go. Okay, so why don't you try one on your own, and then once you're done, come check your answer. Okay, so this is what you should have gotten. Here is your factored form, so that's why you have 2 vertical asymptotes, one at negative 3 and one at positive 1. Okay. Here, because the numerator is smaller than the denominator, the degree, the horizontal asymptote will be y equals 0, also known as the x-axis here. Okay. And then afterwards, I just plugged a couple of points in. So I did since there's an asymptote here at -3, I just did -7, -5, and 2. And then here, between the two asymptotes, between -3 and 1, I just did -2, -1, and 0. Okay. And then here on this side, beyond 1, I just did a couple. I just did 2, 4, and 6. Okay, so I plugged it into my calculator, and this is what it gave me. Okay. And then I plotted the points, and this is what resulted. Right, and so here, even though this horizontal asymptote, that's for this branch and this branch, but for the middle, there's an exception here, and it does cross the x and y axis at the origin here. And then here, we couldn't quite get the shape unless you plugged in some decimal points, but here it's almost looking kind of like a quadratic-ish, but it looks like this way. Okay, so it has 3 branches, 1, 2, and 3. And there you go. That's it for today. Thanks for hanging in there. Have a great rest of the day. Bye, guys.